Do you like large pieces of kinetic art that have lots of motors and moves around and does interesting stuff? Well, you came to the right place. Hi there, my name is Mark Dumas, and welcome to the first episode of a video blog that I'm provisionally calling Laboratory of Irreproducible Results. As a retired engineer, I like to follow the latest developments in electronics and embedded control units, and occasionally I like to use this background to create interesting and fun interactive art. So this is art that engages the viewer by producing some sort of outcome based on feedback from the viewer, and maybe it makes them think in the process. I'm just getting started on an interactive sculpture that may turn out to be fairly large, and it was suggested to me that I should do a video blog on the development of the piece. So here's what's likely to be the first of maybe half a dozen episodes, and I hope you enjoy them. One of my inspirations for this type of art is a guy by the name of Rosen. You can Google him and see that he works in all kinds of interactive digital media, but what I really like are his mechanical mirrors. They're these arrays of individual visual elements, kind of like a pixel, that are on some sort of a motor that can be tilted to catch the light in certain ways and create a sort of a, old style monochrome display. In this particular piece, it's a series of wooden rods whose ends are cut off at an angle, and then the rods are being turned to catch the light in different ways. Again, there's a camera in the middle of this sculpture that's looking back at the observer, and her image is showing up on the piece based on the rotation angle of these wooden rods. You can see a close-up here of how those are being moved to catch the light in a certain way. Okay, so what's it take to build a sculpture of this scale? We could just start off and build the whole thing in one go, maybe get a big piece of plywood, drill a bunch of holes, mount our servos, do a lot of wiring, but we run the risk of finding a problem much later in the design that causes us to have to scrap and restart our work. So what we really need for this project is some sort of a little modular section of the sculpture that we can build, that operates. We can debug it, we can play with it and learn about how it performs before investing the resources to scale the thing up. And since I'm going to be building a bunch of these modules or tiles, I want them to be easy to build. So I don't want to have to deal with lots of little screws and nuts and bolts. I simply want a platform or tile design that I can snap all of my motors and electronics into and build up one of these tiles really quickly. So that's the goal of this first episode, is just to build one of these modular building blocks and see if we can make that work. Turns out that creating this custom tile is a perfect application for a 3D printer. I've been getting up to speed on this monoprice printer for about the past 6 months, and I think it's up to the task. These things have come down in price a lot over the years. This is sort of a middle range of the product line, and you can get one of these for about the price of a smartphone. Looks like we're printing a mount for a bicycle light. And we'll be using SketchUp to create the 3D design. It's got all the functions I could possibly want for this project, and it meets my demanding expense goals, which means it's free. Good product. Similarly, we'll be using Cura to convert the 3D model into commands that the printer understands. Now I've decided right up front to use these SG90 servos from Tower Pro. I'm picking these mainly because they're the smallest and, yes, the cheapest available. Again, that's important if you're putting hundreds of them together. I'm expecting there to be a fair amount of servo failures because these are mass-produced. They use plastic gears and they're, again, super cheap. On the other hand, they are designed to move heavier loads like radio-controlled model airplane ailerons or boat rudders. And so in this sculpture application, they'll just be twirling around a relatively light object, so maybe they'll last longer in this application. I don't know, we're going to find out. I settled now on a tile that will package up 16 of these servos. I did that for a couple of reasons. First of all, a 16 servo tile is something that I can build within the build volume of my 3D printer. Any larger than that, any more servos, it probably would just be too big to fit and build in the printer. And then secondly, 16 servos can be controlled at one time by this printed circuit board. Okay, so all the pins are where you plug in the servos, a little bit of power up here, and signal pins over here. So by packaging up the servo controller card here along with all of these servos, the idea is to come up with one modular product in which all the wiring mess gets a lot simpler. The wiring just stays, you know, kind of with that modular building block, and the only wiring coming into the building block is some power and the serial bus. Now, I want to give out a quick shout to the company that makes this servo controller card. The company is Adafruit, founded by Limor Fried, also known as Lady Ada. And if you've done any hobbyist electronics with Arduinos or Raspberry Pis, I'm sure you've already heard of them. Now, Adafruit produces a lot of good products, tutorials, example code for experimenters and artists. But this particular module is a really good example of what's called a breakout board. What Adafruit does is mount that IC on a board with some support circuitry and all the right connectors. And then they provide the real magic, which is providing really good documentation, tutorials, and some example programs. So Adafruit's one of several companies I'm aware of that provides this vital bridge that gets the latest tech stuff to the masses in a form that's easy to use and allows makers to get productive on what they're good at more quickly. All right, so I've been through several design iterations on the tile, and this is the first one I came up with. Real simple, basic platform with some special holes built in for the servo motor, and they just kind of snap in like this, just sort of a friction fit. These little blocks and pins were my original thought on how to do a fastener-free kind of assembly, but these little pins are obviously too small to do any good. I've already broken most of them off. The main thing that I learned too from this design is that I had the spacing of the motors a little too close together. There was actually going to be some interference of the servo cases with one another. So then I redesigned to this, and this is where I switched to these clips to clip over the top of the servo, and that works really good. You get a nice satisfying click like that, but you'll see a lot of those clips are broken, and that's because I was having to spread them so far apart in order to get the servo in there, so a little rethinking required there. Also, this is where I started thinking about how to support the servo controller card. I have two pins or two posts here. There's a third one over here that was broken, and I couldn't figure out how to fit a fourth one in there. But the idea is that the circuit board would mount on those, just sort of clip into place. And there were, obviously some issues with that. And then I also started on this particular version trying out these little jigsaw-like plugs and sockets in anticipation of plugging these things together. I never built a second version of this particular tile, so I never really tested it on that one. All right, and then here's the third and kind of final design for the tile. I've shortened the tooth on the clip so that I don't have to spread them quite so far apart in order to get the servo in there. And so it's a little easier to snap them in there. Nice satisfying click there. And then I've got, I figured if I couldn't find a fourth place to put a post for the servo board because the clips were in the way, I'll just put the extra post on the clip. So that's worked out pretty well. And what that does is allow me to clip all four corners of this thing together. So that worked out pretty well. And then I've beefed up these plugs and sockets on the side in order to make a more stable connection between neighboring tiles. So I'm pretty happy with the design of the mounting plate. I think it's going to keep everything held together nice and tidy, and next step is to actually do a build with one of these things. All right, let's build this thing. We're going to take this pile of servos and make them nice and organized with this new tile. We're going to start by plugging in all 16 servos. Those little clips and special size openings make this really easy. It goes really quick. All right. 16 servos on the tile. Now we're putting in the PCB board that controls all 16 servos, and we're plugging the servos into the printed circuit board. All right, there's still quite a bit of wiring hanging out there, kind of a big fuzzball, so let's try and dress that up a little bit and get those wires routed down between the servo towers and make this a little bit easier to handle. I'm using a pair of large tweezers that have blunt ends to help stuff those wires in. Don't want to use anything too sharp or you'll cut the insulation on the servo wires. All right, that's looking a lot better. Now let's flip it over and let's put on something that helps us see the motion of the servos. These are the little servo horns that come with the servos. We'll be doing something a little more artistic in the end product. Looks great. Have a cold one, Mark. Well, that was a very satisfying build. It took about a little bit less than 15 minutes of total elapsed time, and that includes the time to dress these wires and put the little control horns on the back. I especially like the fact that I didn't have to deal with any little screws or nuts and bolts. So everything went very smoothly. So let's test it out. I think I mentioned earlier that the servos are provided power through this blue connector here. I'm going to be using this little wall wart that I found on the side of the road while bicycling, so it meets my demanding expense criteria. I think it's 5 volts at about 2 amps. And the rest of the board is powered up from the Arduino that we're going to be using to send commands over the I2C bus. So there's a black and red wire here to provide ground and plus 5 volts connection. And then the blue wire is the I2C data bus, and the yellow is clock. All right, let's get that flipped over. The first thing we should see with this sketch that I've written is all of the servos should just line up to their center position. Yep, there we go. And now it drops into a loop where it is just doing the wave kind of sequentially back and forth a bunch of times. So it looks like they're all actually working, and after about 10 times of that, I think I've got it. It should go into some sort of a random mode. There we go. It's just picking a random servo and turning it to a random position. This episode has been a great first step in building a large kinetic sculpture, but I've still got a lot to learn about how scalable these tiles are. Things like, do they really snap together, physically speaking, as well as I hope? What about electrically? How do I hook them up and control them from a single Arduino? What about power distribution? What about performance? So the next episode is going to be dedicated to learning as much as possible about how scalable these tiles are before I go build a bunch of them. Beyond that, I need to come up with something a little more visually interesting than these servo control horns. I've got some good ideas in mind there. And beyond that, I need to make it interactive. So if you want to get notified of new episodes, just click on the subscribe button. It's that red button right over, right over there. And if you have any questions or comments about where the project is heading, I'd love to hear from you in the comments section. Until then, keep on making.